Hello friends, today in this class we will discuss about retention factor, which is a means important parameter in chromatography technique. So we will see what is the retention factor. Okay, so before going into that, I want to give a brief description about different terms used in the chromatography. Okay, so this is the column chromatography. Okay, and here you are having different terms in related to the column chromatography. Okay, so first one is the eluent. Okay, so what is eluent? Eluent is nothing but your mobile phase, you can say. Okay, eluent means fluid entering the column. Okay, or you can say it is the mobile phase. Okay, and then you are having the analyte. Okay, analyte is the mixture whose individual component have to be separated and analyzed. Okay, by using the chromatography. Okay, so it is the mixture of component and which will be analyzed. Okay, so that is the analyte. Then this is the column. Okay, then you are having stationary phase as a solid or as a liquid. Okay, and solid phase is the substance that stay fixed inside the column. Okay, it will be fixed inside the column. Okay, mobile phase is solvent moving through the column. Okay, so outside of the column it is called as the eluent, and once come into the column, when it moves it is called as a mobile phase. Okay, then you are having cotton plug as a knob. Okay, closing knob. Okay, and this is the eluate. Eluate means fluid existing the column. Okay, that is collected in the flask, that is called as a eluate. Okay, elute, or you can say elute, and it is the eluent. Okay, eluent is the fluid entering the column. Okay, and elution is the process of washing out a compound through a column using a suitable solvent. Okay, so this thing you have to remember, like mobile phase is solvent moving through the column. Okay, when it is outside of the column it is called as the eluent. Okay, and then second is the stationary phase, which is fixed in the column, that is called the stationary phase. Now you are having eluent, which is fluid entering the column. Elute is fluid existing the column, and elution is the process which washing out a compound through the column. Okay, using a suitable solvent. Then you are having the analyte. Analyte is nothing but it is the mixture of component that has to be separated and analyzed. Okay, then now we will see what is the RF value. So RF value is nothing but it is the retention factor, or it is, you can say, like it is the retardation value. Okay, it is the retention factor, or it is a retardation value is a measure of the position of a component in the chromatographic separation. Okay, so it will tell you like how much distance your component is traveled. Okay, with respect to the solvent front. Okay, we will see like how to calculate this RF value. So it is nothing but it is the retention factor, or it is the retardation factor, which is applied by the stationary phase. Okay, means how much time the stationary phase can retain the analyte with it. Okay, or it is retarding to, like not interacting with it. Okay, it is retarding the molecule. Suppose there is a same nature of molecule, then what it will do, it will retard it. Okay, it will not interact with it to retain it, it will retard it to elute out first. Okay, so how much time it will take to retard it, or how much time it will retain with it, that is called the RF value. Okay, so it will if normal way we will tell it is the we will tell it is the measure of the position of component in the chromatographic separation, means how much distance any analyte is traveled. Okay, then a given component will always travel the same distance in a given solvent under the same condition. Okay, so theoretically if you are giving the same component, okay, means most of the time we have to perform the experiment in triplicate. Okay, so suppose in the given component is same in both the chromatography technique, so they will travel the same distance. Okay, if suppose it is traveling this much distance, so in another chromatography also it will travel this much distance if the solvent is same and if all the condition is same, then it will travel the same distance. Okay, and this RF value indicate whether the analyte or solute prefer the stationary phase or mobile phase. With the stationary and mobile phases, RF value are used to determine it is determine how it will tell you it preferring the stationary phase or mobile phase based on the polarity, their relative masses or relative solubility, and among other things also. Okay, so these are the three major thing, it is the analyte is more polar with either a stationary phase or either mobile phase. Okay, so based on that it will tell the RF value, and it is based on the relative masses also it will tell the RF value, and the solubility means it is more soluble in mobile phase or more soluble in a stationary phase, that also we can identify the RF value. Okay, so yeah, so how we will calculate the RF value, you have to distance traveled by the component divided by distance traveled by the solvent. Okay, so this is the paper chromatography suppose, or you can say the thin layer chromatography. Okay, so here what is the thing is, you are having, this is the solvent level. Okay, or and this is the solvent front. Okay, solvent level and solvent front. Okay, so you have to calculate the distance traveled by the component. Okay, after passing the mobile phase, how much distance the component is traveled. Okay, this is the analyte mixture, this three thing is the analyte mixture, how much distance it is traveled. Okay, so that distance divided by distance traveled by the solvent. Okay, so suppose you dip the paper onto the solvent, so how much distance the solvent has traveled. Okay, so that will be in the denominator. Okay, this is the baseline. Okay, so here in the solvent level, from solvent level to solvent front will be your A, or you can say like distance traveled by the solvent, and this from baseline to whichever you, if you are talking about this green molecule, then it is the B. Okay, means this is distance traveled by the component. Okay, so here we generally consider the center of the molecule. Okay, because it is the real means distance traveled by any molecule, it can be thin also, it can be rectangle also, it can be circular also, so that's why we always consider the center of the molecule is the real distance which is traveled by it. Okay, so this is the B. Okay, so retention factor equal to B divided by A. Okay, and another thing you have to remember is this retention factor should always be less than 1. Okay, it should be always be less than 1. Okay, because here the solvent distance, the solvent will distance more comparative to the travel the distance more comparative to the component or analyte molecule. Okay, because it is only moving the it is only helping to move the component, right? So the mobile phase or the solvent the distance traveled by the mobile phase or traveled or solvent will be always greater than the distance traveled by the component. Okay, because here the solvent is moving the component. Okay, so that's why, and the RF value should be always be less than 1. Okay, if you are getting greater than 1, then there is a problem. Okay, so there, and that data is not reliable. Okay, so an ideal RF value should be always be less than 1. Why? Because here your solvent molecules mobility is higher than the your component mobility, because your solvent is only helping in the passing through this stationary phase. Okay, so that's why. Okay, then the RF value is affected by the interaction of various component. Okay, like if it is interacting with the components like either mobile phase or either stationary phase, it will affect the RF value. Like if it is interacting more with the stationary phase, okay, so what will happen, it will travel less, or it will pass less distance, because it will attach to the or fix with the stationary phase. That's why it can not travel much. Okay, or if it is interacting with more mobile phase, then it will travel fast. Okay, so the same thing it is saying, like RF value is affected by the interaction of various component, as well as the concentration of component in the sample. Okay, so suppose your component concentration is very much high, then what will happen, while moving, it will diffuse. Okay, if concentration is very high, then it will diffuse. Okay, so if it is diffuse, then you can't particularly identify like what is the RF value. Okay, so apart from that, the temperature is also affecting the RF value, since the solvent can often better dissolve the chemicals, or the mobile phase can better dissolve the chemicals if it is transporting at a higher temperature. Okay, so in higher temperature, the mobile phase is dissolving the chemical much better, so that's why the RF value will be higher. Okay, if the temperature is low, then it will not solubilize properly with the mobile phase, so the RF value will be less. Okay, so these three things you have to remember, like the RF value is affected by the interaction of various components, as well as the concentration of component, it will be very high, that time also it can affect the RF value. And it also affected by the temperature, because solvent can better dissolve the chemicals while transporting at a higher temperature. Okay, so regarding this RF factor, in 2017 one question has been asked: in a thin layer chromatography experiment using a silica gel plate, a compound showed migration of 12.5 centimeter, and the solvent front showed migration of 18 centimeter. The RF value for the compound is. Okay, so what it is saying, in a thin layer chromatography, here the solvent is filled with the solvent. Okay, and here one glass plate is there, which is coated with the thin layer of silica, which is act as a stationary phase. Okay, and here your compound is there. Okay, I will take another color, suppose. Okay, this is your where you positioned your compound firstly. Okay, so after certain time, okay, what it shows is the suppose this is the base. Okay, this is the base of solvent. Okay, and this is the solvent front. Okay, means till at a particular time, the solvent has moved here, and the molecule has traveled this much. Okay, from I will, like what I can tell is, from here. Okay, suppose here to here it has been traveled. Okay, so this is from here to here it is travel, that is the B, and the solvent has traveled from here to here, that is A. Okay, the A has been given 18 centimeter, okay, because my and the solvent front showed the migration of 18 centimeter, okay. 18 centimeter it has been traveled, okay. So solvent has traveled 18 centimeter and molecule has been traveled 12.5 centimeter, okay. So what you have to do is RF factor equal to 12.5, okay, then 18 centimeter. When you divide it, how much you will get? 12.5 divided by 18, so it will come around 0.69 centimeter will be the correct answer, okay. Because here both the things are in centimeter, that's why the answer will also come as a centimeter, okay. 0.69 will be the correct answer. Got it? So how we found is, I will first like suppose okay, this is a, in a better way I will prepare once, okay. So this is glass plate and it is filled with the, suppose, uh, solvent molecule, okay. And here you are having your here suppose you are having your analyte, okay. So this analyte, at a certain time, this analyte suppose move from here to, sorry it is not visible, okay. This analyte is moved here to here, okay, at a particular time, here to here suppose, okay. Then uh, on that particular time also this solvent is passed from here to, this is the suppose base, so here to here it has been passed, okay. So this is A and this is B, okay. So in the formula we know that the RF value is B divided by A. So B here it is written by like a compounds on migration of 12.5 and solvent front showed migration of 18 centimeter, okay. When you divide it you will get the 0.69 centimeter, okay. So this will be the correct answer, okay. Got it? So that's